Hello, and thank you for having me speak today. I'm sorry I couldn't join you live, but I hope this talk encourages a good discussion, and I look forward to meeting all of you at the networking session and coffee break tomorrow. So I'm going to talk to you today about some advice I have for graduate school applications, both master's and PhD. I'm Abby Stevens. I'm a postdoc in the US at Michigan State University and the University of Michigan, and I'm also an instructor in general sciences at Michigan State University for this semester. So the outline for today, I'm going to tell you a bit about who I am and why I'm talking to you about this. I'm going to go over some of the differences between the US, Canada, and Europe. So all of this advice is based on my own personal experience in the education systems in the US, Canada, and the Netherlands. I'll then go through some general application strategies and some tips for writing your actual applications. We'll then talk briefly about letters of recommendation, which are a very important part of your application. I have some advice for what to do once you're accepted to some programs, and then some more general advice at the end. At the end, I'll have some more resources, which are pretty much links for you to look through later. I'll make a PDF of these slides available, and the conference organizers can distribute those to you. So let's start. So as I said, my name is Abby Stevens. I grew up in the US. I'm from Rochester, New York, which if you look at a map of New York State, is right there, very far from New York City. This is a picture of me at my high school graduation. I went to an international baccalaureate school, so I did math, physics, and computer programming in high school to set me up for going to university. Then for university, I went to a small liberal arts college. This is pretty much a US thing. So I have a BA, a Bachelor's of Arts, in physics and in math. At Bard, I did a full year research project in my last year, in my fourth year of university. And this is a picture of me with my poster for my research project that year. I was doing some mathematical physics on black holes and kind of how different equations of motion work for 2 plus 1 dimensional spacetime versus 3 plus 1 dimensional spacetime. It was really fun. And then from Bard, I went to graduate school for a master's degree at the University of Alberta, which is a large research university. At the University of Alberta, so this is Canada. If you're familiar with the US, this is Idaho and Montana right here. So Edmonton, Alberta is like I don't know, 6 or 7 hours straight north from like the skinny part of Idaho and Montana. So the University of Alberta is a very big public university with a great physics program. And we had a Department of Physics there, so my degree is in the astrophysics group. And here's a picture of me giving a talk at Nerd Night Edmonton, which was a ton of fun about exoplanets. Not my research topic, but really interesting and fun to talk about. So I did just a master's there for 2 years. And then after University of Alberta, I went to the University of Amsterdam for a PhD in astronomy. So here's Europe, the Netherlands is up here, and Amsterdam is right there. So here I was at an astronomy research institute, which was part of the large University of Amsterdam. And this was fantastic. It was like, I don't know, 60 or to 80 astronomers all together. And it was a very focused degree. I didn't have any more coursework to do. It was just research. So I was paid as a research assistant, and I did a little bit of teaching assistant as well. This is me in the first year with some of my colleagues at the Westerbork Synthesis Radio Telescope. I'm in the silver right there. And since finishing my PhD, I have been in Michigan. Again, here's the US, and Michigan is the one in the Great Lakes that looks like a hand. And I split my time between two universities, Michigan State, which is right here, and University of Michigan, which is down over here. I have a US National Science Foundation Fellowship in Astronomy and Astrophysics, and also this semester I've paused that fellowship to be teaching Introduction Astronomy to non-scientists, which is a lot of fun. So this is my background. And so the advice that I'm giving you is based on growing up in the US, going to do graduate school in Canada and Europe, and then coming back to the US as a postdoc and seeing how graduate applications work in the US as well. So I'm going to go over some of the differences between the US, Canada, and Europe for how the degrees are structured, because they're all quite different. So in the US, the master's and PhD are combined. So you always apply for the PhD program. Even if you just have a bachelor's degree, always apply for the PhD program. Once you are in the program, you can switch supervisors fairly easily. This is because of how the funding is structured for having graduate students in the US. Especially in the first few years, it's usually quite straightforward to switch advisors. There is a very strong emphasis on coursework for this, and some or many, I'm not sure exactly, how many. Some of these programs have candidacy exams. This is an exam that you sit um, after you finish all of your coursework before you formally become a PhD candidate. Sometimes these are written exams, sometimes these are oral exams, but this is a very common thing to have in the US and sometimes in Canada as well. Your funding when you are a graduate student in the US, you are often a teaching assistant while you are taking courses in your first few years, and then you transition to being a research assistant paid for by your advisor's research grants later on. In the US, not all programs offer healthcare. This is something to be very aware of and look at the benefits of the programs you're accepted to. They usually have decent vacation. You don't normally have to register your vacation days. There are no retirement contributions, as far as I'm aware, of any graduate programs in the US. Um, they have a pretty flexible timeline. The master's and PhD all combined can take maybe 5 to 8 years, depending on who you are and where you are, and if you switch your topics. This is quite flexible in part because there's a lot of funding to have people on as teaching assistants, and so this makes it easier to extend your timeline a bit. Now, if we compare to Canada, the master's and the PhD are separate. So if you hold a bachelor's degree, you must apply for the master's. If you have a master's, you can then apply for the PhD program. If you want to stay in the same program as you start with a master's, um, some places will allow you to kind of fast track to PhD. So you stay in the same program with the same advisor without having to do a separate application. This tends to happen after your first year of successful coursework and making some progress with your research topic. Um, in Canada, the programs are funded, though not very well, not as well as most places in the US. You are a teaching assistant for the most part, occasionally a research assistant, depending on your supervisor's funding situation. You do have to pay tuition, though it is usually affordable on your stipend. So when I was a master's student at the University of Alberta in 2012 and 2011, the tuition was maybe like 2 or 3 thousand Canadian dollars. So you effectively net like the poverty line, but it was okay because all of your other friends are in graduate school as well. In the US, you do not pay tuition. That is paid for by your supervisor or by the department. Um, in Canada, you have very good healthcare that comes out of the taxes. You have decent vacation, just like the US, and I'm not sure about the retirement. I don't think we had it at the University of Alberta, at least when I was there in 2011 to 2013. There's also the timeline strictness really depends on the funding of your department and of your advisor. Then in Europe, I'm sorry, my face is covering the E, but it's there. In Europe, the master's and the PhD are also separate. So if you have a bachelor's, you must apply for the master's. The master's degree is mostly coursework, and the PhD is mostly or only research. So when I applied just for a PhD program because I had a master's degree from Canada already. When you are applying for a PhD, you're working with a specific professor on a specific research project, so it is not possible to change your advisors, and it is generally not possible to change your topic very much. Things do change a little bit as you're going just because of how research tends to work, but you shouldn't expect to switch from working on exoplanets to working on distant galaxies. The master's is not funded at all. You have to get scholarships to go. Sometimes people get scholarships from their home countries, or they can get a few scholarships available in the host country where you're studying, but there's not too much of that. The PhD is very well funded in the Netherlands, and it is generally quite well funded in other places where you go. So this was great. The PhD also has good benefits. You get great healthcare, great retirement, and you get good vacation time. This was really helpful for me as well. Especially being so far away from my family, this meant that I could afford to fly back to see my family every year, which was really important to me. In Europe, the PhD generally has a very strict timeline because your PhD funding is a specific project funding with your advisor. So in the Netherlands, it was a quite strict 4 years. So in total, I spent 6 years in grad school, 2 years in Canada, 4 years in the Netherlands. My general advice here is to never do a PhD if it is not fully funded. Some masters are, some aren't, depending on the country's educational system, but the PhD you should never do if it's not fully funded. Um, And then I know that for in Europe, Germany is quite similar to the Dutch system. The UK has some similarities as well, and I admit I don't know as much about the like French, Italian, and Spanish systems, but from my understanding is they're quite similar to the Dutch and German systems that I'm familiar with. So here are some application strategies. The first one is to talk with your advisor. I don't know if you have an academic advisor and a research advisor, or if they're just the one person, but talk with them and listen to their advice. Where do they know people? Where do they have research colleagues? Where do they recommend? And where do they not recommend? This is also important to get at. Sometimes some place might be good for some types of students, but not good for other types of students, and your advisor will know you and they will know where to suggest you apply. You should also ask where recent graduates of your school went on to get their PhD. This is helpful to learn about maybe some programs that aren't as well known but still very strong in their research areas. This can be a nice way to find out other places. And you can also talk with those recent graduates and get their opinion of where they're studying for their PhD. I also recommend chatting with graduate students and postdocs and profs who work in areas you're interested in. You could do this at workshops like the one that you're at SACNAS in the US, at regional astronomy and physics conferences. Talk with them about their research and ask what kind of classes are most helpful for studying in that field. If you're not ready to be doing research there yet, because you're just applying for graduate school, asking about the coursework that leads to that type of research can be very helpful. I also strongly recommend emailing the professors you want to work with before you apply or as you apply. And you should be applying to places where you are excited about at least 2 or 3 professors' research. If you're only excited about one professor's research, you can apply, but be cautious that professors don't always stay at the same university. Things happen in their lives that might cause them to move or might cause them to leave. And so you want to have kind of some different options that you're excited about at the same university. When you're emailing these professors, be sure you address them with the correct pronouns. So when I get emails that say, Dear Sir, I delete them immediately because it means the person doesn't know anything at all about me. That means they haven't looked at my website and they haven't seen anything that I've written. So when you email them, tell them just very briefly, you don't need to give them your whole life story, but briefly, this is your name, this is the university that you study at, you are interested in applying for the graduate program at their university, you find their research interesting, are they accepting any new students, or are they going to be looking for any new students in the coming year? That's the general gist of what to say. The professor might reply very briefly. This does not necessarily mean they don't care, just we get a lot of emails and we don't have as much time to reply to them. So don't write giant paragraphs, just kind of keep it brief, but provide the information that they need. And also, as you're doing your applications, you should be preparing well in advance. So most deadlines are November to December, so you should start looking and working on this in like September or so. A lot of times professors are finding out about grants that they receive in August to October, I think. So this is when they start to know if they will have extra funding for new students. And when you are writing your applications, you're often writing 2 main things, a personal essay and an academic essay. I took a lot of these tips here from the Michigan State University guidance for graduate applications. The link is down here that you can click in the PDF version. So in the personal essay or personal statement, they often ask you to describe maybe extracurricular activities or hobbies that you engage in particular activities that you've led or new initiatives that you've started. They want you to give an example, usually of a time when you hit a serious professional or educational obstacle or failure and how you overcame it. Um, Knowing how students can overcome obstacles is a very good indicator of how they might do in a graduate program and seeing how they overcame the obstacle because graduate school is just very, very difficult. They will want to know what professional or educational accomplishments you are most proud of and why, and to give a general appraisal of your strengths and weaknesses as it relates to graduate study. So this is still not like your life story. It's still as it applies to academics and education, but it is more about you as a person. There's also the academic essay, which might be called an academic statement or a research statement. In this, you want to describe any research you have done to date. This could even be research that you've done as part of a bachelor's course or something you've done over the summer with a professor at your university or a different university, and any internships related to astronomy and physics, or even tangentially like in engineering that you may have done. They want you to describe your research interests and what you are interested in studying at that university. This is where you should specifically indicate, if you are applying to a department of physics and astronomy, be sure to indicate here that you are interested in the astronomy and astrophysics program, or also maybe astroparticle physics and high energy physics, if that's where your interests lie. It is okay to be interested in more than one topic and more than one faculty member. They do not want somebody who thinks that they want to do everything from astronomy to high energy physics to nuclear physics to condensed matter physics. That is too broad and shows that this person doesn't really know what they want to do. But it's okay to say I'm interested in high energy astrophysics and also astroparticle physics like neutrinos. That's totally fine. Or even exoplanets and maybe neutrinos. And this is where you also want to indicate specifically the faculty members that you've been emailing with and who you're interested to work with. You should describe in general your long-term career goals, where you would like to see yourself ending up in maybe 10 years or so, and explain how a graduate degree in astronomy and astrophysics fits into those plans. This is where they want to check that you've thought about what this degree means, how much work it's going to take, and your reasons for wanting to do this. And also, many places want you to describe your experience with computation, whether you have written your own computer programs to do any research or academic work, if you got very high marks in a computational course that you took, if you've worked on any servers, like if you've run simulations on servers, which you don't necessarily have to have done, but just any experience with computation to show that you know that computer programming is a part of astronomy and astrophysics and have some basic competency, they would like to hear about that. However, all of these things that I have said, this is all general advice taken from the guidance to apply for MSU. So be sure you cover whatever specific university program asks you to address. So if they ask you to address something that's not in here, please be sure to address it. And if they give you a shortened space to write things, you can remove some of the things that I've recommended here and be sure you cover what they ask you to address. That is the most important part. When you are writing your applications, I recommend iterating drafts with your advisor and perhaps even a writing tutor in English on these graduate school application materials. The first draft you write is often not the one that you submit. This is still true for me. So going over it with your advisor, perhaps some of your classmates who are also doing applications, and I strongly recommend a writing tutor. This can be very, very helpful. And this is also why you start working on these things like at least a month or two in advance, because iterating takes time. For the applications, there is something called the GRE in Physics GRE. It stands for Graduate Requisite Exam. This is for US programs. More and more places are not requiring them, which is great news. These are standardized exams that are very expensive to take, and you have to go to certain specific locations to take them. There is a link in the PDF you can click on that tell you about the places not requiring the GRE and the Physics GRE, which is fantastic news. There are application fees at most universities in the US and Canada. So this is that they charge you money to apply for their program. It tends to be about 50 to 100 US dollars each to each place you apply. In Europe, I don't know if the master's has application fees. The PhD definitely does not have application fees in Europe. Some of these places have fee waivers, so you can submit a small application to say I'm unable to pay this, and then they don't make you pay that fee. So note that this money goes to the university, not to the physics or astronomy program. So the physics or astronomy program often does not have the power to just stop these fully, but they do have some fee waivers, so you can ask about those if you need them. There's also the TOEFL. I know this is very contentious. My hope is that the TOEFL goes the way of the GRE soon. This is required for most US programs if your degree is not from an English language university. The Canadian programs may require the TOEFL or the IELTS. I'm not sure exactly. Check with the specific universities you're applying for, but the TOEFL is often required for most of these places. Now, as we talk about another important area of your application, these are letters of recommendation. You usually need 2 or 3 of these for each application, and you will use the same letter writers for all of your applications. You should pick professors who you have done research with or done a final project in your class. And if you have an advisor who's separate from that, then that person. Your advisor and maybe your research professor can also be good people to talk with about who else you should ask to be your letter writers. When you are asking for a letter, I recommend using something like the phrase, do you think you could write me a very strong letter of recommendation for PhD applications? When you ask this, know that their answer might be no, I don't think I can. And that's fine. I've had people say that to me. Sometimes it means that they just don't know you well enough or haven't worked with you long enough to be able to write a long, good letter. And they might think well of you, but just not have enough examples that they could write a really strong letter. And you want a strong letter. So this is why I recommend asking this specifically. When you are asking for these letters of recommendation, give your letter writers about 4 weeks notice before they are due that you would like that you would like these letters, because they can't write them in just one day. And often professors are writing many letters for many of their different students all throughout the fall, all throughout September through December. So give them advanced notice that you would like to have them write these letters. Highly recommend it. When you are asking your letter writers, you can ask them to include specific pieces of information to explain any discrepancy in your transcript. Like, for example, if you had health problems and that's why your grades dropped one semester, or if you had a big family emergency and this is why you missed an exam and your grade was poor in this class. Any discrepancies like that, you don't have to write about them in your application, but ask your letter writer to mention them, so that way it's explained why that happened to the people that read your application. Hopefully, once you go through all of this, typically people apply to, like, I don't know, 10 places or so. Talk with the professors and conference organizers that are there with you. Hopefully, once you do all of this, you have some acceptances. And so once you're accepted, talk with the professors that you want to work with, talk with the other graduate students in their program, and see how happy they are and how much they might recommend the program. When you're doing this, these tend to be short conversations over Zoom, so it's hard to get a full sense of how you and the professor might work together. But this is kind of one of the best ways you have to indicate this. When you talk with graduate students, you're talking with ones not only in that professor's research group, but also ones outside of that, because they might still, they see the professor in the hallways, they have that professor for classes. So talk with them to see how people think about the program in general and how people think about the professors that you would like to work with. Also, when you're talking with them, get a feel for the location where the university is and whether you think you could realistically live there for like 4 to 6 years. If it's a master's, it's only 2 years, but if you stay for a PhD, it could be 4 to 6 years. You want this to be a place where you think you could live a decent life. It doesn't have to be your top number one location, because you will be spending a lot of the time doing your coursework and doing your research, but you do have a whole life. And it's important that you think you could be pretty happy there. Don't count places out immediately because of the location. Like, for example, living in Michigan is quite nice and quite lovely, but this isn't the expectation everybody has immediately. But you can adjust quite well to some places. But for example, I really, really dislike very, very hot and very, very humid places. So I wasn't applying for anywhere that was very, very tropical, just because I know that I would not be very happy there long term. So keep this in mind. And also, if you're part of an underrepresented demographic, for example, if you are Latina or Latino and you don't see anybody else from that demographic at that school, ask some questions. Ask it of your mentors, ask it of the graduate students there, to figure out whether, because sometimes there's a problem. There's some kind of problem that is kind of driving people away. Or sometimes, if it's a very small program, there just don't happen to be any Latino or Latina students there at that time. Or sometimes there's a problem that keeps driving them away. So if I was looking at places and I didn't see any women, like not even white women, I would kind of ask, how is this place for women? Is there just not happen to be any female students here at this time? Or like, have they started here and then left because they didn't like it? So just kind of ask around just to check that it's like going to be a happy, healthy place for you to be living and working. Some more general advice I have is that so there is kind of a mental health crisis happening among graduate students. I have a lot more resources on my website that point to a variety of other places and articles and studies that have been done. And also, just graduate school is really hard, like mentally and emotionally, even for people who don't have any issues with like anxiety or depression or homesickness or anything. Um, when you're doing the research, and especially when you're first doing big research projects like in graduate school, you are pushing yourself, you're pushing your brain just as hard as it possibly can over and over and over and trying new things. And this gets really draining and can get quite tiring. So I recommend getting in touch wherever you do start for graduate school. I recommend getting in touch with the counseling and therapy services at that university just to have check-ins every so often, just to be sure that you're taking good care of yourself. Um, Part of why I emphasize picking the right professor is that advisor fit is a good predictor of mental well-being in graduate students. So basically, your advisor can kind of make or break your graduate school experience. So talking with the professors who you would like to work with and talking with their students and the other students is something I find one of the most important things to do. So, for example, having a great advisor can help you find a niche that really plays to your strengths in whatever field you find interesting. However, having a negligent advisor can kind of amplify feelings of loneliness and isolation, which can cause you to dislike a research topic that you might otherwise think that you love. Um, so I know it's tricky to judge the quality of a working relationship from just short interactions, but chatting with graduate students, both in their group and not, can help you to fill in the picture. So for example, if you think that if you're interested in high energy astrophysics in general, and relativity in general, picking a professor who works in that general area but might work in some different little topics within there, that's fine. As long as it's some topic that you find interesting, a great advisor will help find a project and have a project that will work really well with you. Maybe you want to do a lot more computation work, or maybe you want to do a lot more observational analysis. A great advisor can help you figure out how to fit that in with your strengths. Whereas a negligent advisor, but somebody who's working in a topic that you truly love, if they're not if they're not able to be a good advisor to you to help guide the research project, or even if there are some very bad advisors that try to hurt your research progress, this can be just really, really terrible. So yeah, I recommend picking a good advisor is the short answer. Also, international experience is often necessary, but I found it quite fun, especially if you are not in the US. Most countries have a kind of unspoken rule that you must leave and get experience abroad in order to come back and get a permanent position there, if that is your ultimate goal. Um, so, traveling around is a lot of fun, but it can also mean living and working away from your family, which can be quite difficult. There is a lot of rejection as you're applying for these things. And then once you are in graduate school, you might apply for some research grants, or you might apply for some observational time or some computer time. There's a lot of rejection, but it often isn't personal, even though it seems that way. So it is normal to feel sad once you have experienced rejection. But once you're done with that, see what lessons you can learn from next time, because there often is a lesson in there somewhere. Um, yeah. And also to celebrate the successes when you have them, because there are not too many successes as you go along the way. So when you have a paper accepted, or when a friend of yours gets into their favorite program, celebrate these things. It's very important to find the good bits and hold on to them. Mm, yeah. So this is the end of the advice that I have for you. I have some more resources. These links you can click in the PDF version. Professor Sarah Markov from the University of Amsterdam is a prestigious research professor who has a very long talk that is not only about how to apply for graduate school, but also postdocs and setting yourself up for like top faculty positions. So if you're looking for that kind of career path, I recommend looking through her slides on landing a permanent position. She calls it how to apply for stuff. There is also the Astro Better blog and wiki. This has the blog posts have a variety of different advice bits from professional astronomers. Um, and I also wrote a blog post about going to a Canadian master's program with a bachelor's from the US. And I wrote a follow up about going to a Dutch PhD program with a Canadian master's. So those might be helpful. It's most of the same advice that I've been telling you here, but it can be nice to read it again. And the wiki is a community contributed area with all kinds of advice for applying to programs and getting research time and setting up your computer and traveling for conferences. I mean, it's full of really good information. There's also a Twitter thread from Dr. Nicole Cabrera Salazar about applying for about what to do once you're accepted to graduate programs. Basically, she also really emphasizes looking for advisor fit. So she has a bunch of great advice in her Twitter thread. And also, when you are looking for typically PhD positions, the AAS, so American Astronomical Society Job Register, and the European Astronomical Society Job Directory both have listings of these places, of places that are hiring. A lot of places in the US will not advertise on those two places, but they are often still taking applications. But these can be nice places to look if you are looking at graduate school outside of the US and Canada. So with that, I hope that you find some of this advice useful, and I hope this encourages some good discussions at the rest of the session. And I look forward to answering your questions and talking with you all tomorrow at the networking session. Thanks very much. Bye.